So I will be focusing on the first conic section, which is the circle. So what is a circle? So this is basically a review of your previous year wherein you were not able to finish, and it is defined as a set of points on the plane that are equidistant or constant, and this constant is what we call as the radius from a fixed point, which is called the center. So the center is there, and we have here that is from this point to this point on the circle. So from the center to any point on the circle, that is what we call as the radius, or if it's more than one, we call it radii. And of course, if we are going to connect two radii, that makes one chord, a special chord, which is what we call as the diameter. So this is basically what we will be focusing on. We'll be learning how to identify the center. So in a circle, the center is of two values, the x and y, which is denoted by hk, which is the center. So if it's on the origin, so if this is a quadrant, if it's in the origin, so it's 0, 0, and if it's not in the origin, so it's the hk. And we also have to identify the radius of a certain circle. And instead of plotting it manually, this time we have to use the app. You can use the GeoGebra app in plotting or in graphing or sketching the graph of a circle given a standard form, because it's very difficult this time to really illustrate it manually, the graph. So we will just apply the GeoGebra app in the graphing. Okay, so we will focus more on center, radius form, as well as in general form. So the standard form, or what we call as the center radius form, is denoted by this form: quantity x minus h raised to the power of 2 plus y minus k raised to the power of 2 equals r squared. So I separated the color for h and k so that you will be able to identify that this represents the center. That's why it's also called the center radius form. And the r here is the radius, so you get the square root of r squared, we get the radius. So the center here is h, k, so h is the x and the k is the y, and the radius is denoted by r. And then in general form, we get this form: x squared plus y squared plus dx plus ey plus f equals 0. So it was also written in your learning kit how we arrived at the general form, so I'll not anymore give a further discussion on it. So we have here the formula in finding for the center as well as in finding for the radius. So for the center, it is the h, right? So it is denoted by negative of d over 2, and the k is equals to negative e over 2, and the radius is the square root of h squared plus k squared minus f. So we will be using this formula in some problems that we will be solving later on. So let's have one example. So transform the general form of the circle: x squared plus y squared minus 10x plus 4y minus 7 equals 0 into standard form. Into standard form is again in this form, or the center radius form. We call it center radius form because you can immediately get the center, which is denoted by hk, and the radius here. So we have here another is to find the center and the radius. So the first step here is that we copy this general form, and then we are going to combine or arrange them such that the x are of the same, or are written first, plus the y and plus a constant. Now if you notice, this is plus 7 here. It's because one way of transferring the 7 here is you add, it's added, the additive inverse of negative 7, which is plus 7, or we add it both sides, or we can also use the transposition method. So the negative 7 here, transpose, that becomes positive 7. So applying the formula for center HK and radius R, we have here H is equals to negative D over 2 and is substituted. So D is negative 10. So this is, if you're going to take note of that, the coefficient of X is D. So that is 10, negative 10 over 2. So negative times negative is positive, then 10 over 2 is 5. So positive 5. Well, for K is the coefficient of Y, so that is 4 over 2, then it's negative, so it's negative 2. So therefore, we can find the radius as well. We have here, since the formula for the radius is h squared plus k squared minus f, so substitute plus 5 squared plus negative 2 squared minus negative 7. Since the constant is, the original constant is negative 7, equals the square root of 25 plus 4 plus 7 equals square root of 36 minus 6. So, equals square root of 36 equals 6. So, that is the radius, which is positive 6. So, we have here the center, which is 5 and negative 2, and the radius of 6. So, changing it to standard form, x minus the h, which is 5 squared, plus y minus the k, which is negative 2, then squared equals 36. So simplifying it, so x minus 5 squared plus y plus 2, it becomes plus 2. It's because negative times negative squared and then equals 36. Okay, so that's one example of finding for or in solving circle problems. Okay, so let's proceed. This time, let's have another problem. Example 2. Transform the general form of a circle x squared plus y squared plus 2x minus 6y minus 15 into standard form. Then find the center and the radius. So it's the same question in problem number 1, but this time we are not going to use the first method, which is the formula of the HK and the R. This time we will be using the completing the square method. So if you forgot the formula of the HK as well as the radius, so you can use completing the square method. So how do we do it? The first step is we are going to rearrange according to x and y terms. So we rearrange just like what we did in the previous example. So combine the x and the y and as well as the constant. Then to transpose the constant, so to eliminate the minus 15 constant here, so add its additive inverse, so negative 15, inverse of that is positive 15. Both sides to balance the equation, so that's why this will be cancelled, so 0 plus 15. So that's also what the process we commonly call as transposition. Then the next step is we are going to find the missing values. So these purple values here, this one here, are actually the missing constant. To change it into to complete the perfect square trinomial. So since we can solve this one, finding for the perfect square trinomial, it's a trinomial because it has 3 terms for the x and for the y terms. So we have here, how did we get the 1? So we use the formula b over 2 squared to solve for the missing constants both for the x and the y group. So, and add all the constants to the right as well to balance the equation. So we have here the formula. Since b, remember the ABC in the quadratic. So the b is the coefficient of x in the trinomial. So 2 over the constant 2. So we have 2 over 2 is 1. Square root of 1 is still 1. And for the y, we have negative 6 over 2 then square it, so that's negative 3. So negative 3 squared is 9. So since that's why we get 1 and 9 here, and to balance the equation, we will also add the 1 and the 9 on the right side. So we get a perfect square trinomial, which is x squared plus 2x plus 1. And also here, y squared minus 6y plus 9. So they are all perfect square trinomials. And then the constants that were added to balance the equation. So change to square of the binomial. So to get the square of the binomial for this is x plus 1 squared. How did we get that? So the square root of x squared is x. And the square root of 1 here is 1. And then copy the middle term, the sign. So that's why it's x plus 1 squared. You will try it. You will get this one. For the y also, it's y. Square root of y, and then minus, copy the sign, and then square root of 9, which is 3, and square it equals, you add it, there is 25. So this is the center radius form, or the standard form. So this is the center, the radius form. Another name for the standard form, we have this. And then, so therefore the center is negative 1, 3. So take note that's negative, negative 1. So that becomes positive. So x minus negative 1. So if it's plus, that means that h there is negative. And its radius is the square root of 25, which is 5. So if I'm going to show here the circle, this is the sample circle. So we have here, this is, I use GeoGebra app, so this will appear once you type the general form. So this is the one that you will write, not this, but it will not appear if it's in standard form, but in general form, like this. And then you locate the center, so this is negative 1 here, and then 1, 2, 3 is here, then that's 4, that's 5, so this is positive 3, so it's negative 1, positive 3, this is the center. And then of course, by GeoGebra app, we were able to find the radius there, which is equals to 5 units. Okay, so that's the next example. So let's proceed to the other example. For the third question, find the center and radius, and then transform the standard form into general form of the circle. So given a standard, we will change it to general form. So the first step here is to identify the center, because we can immediately find the center here. We have negative 5. Since it's plus 5, so it's negative 5, because it's x minus negative 5. And then 1 minus 3, so it's automatic that 3 is the k. And then the radius is the square root of 49, which is 7. Now that we have that, so to expand, we will expand to change it to general form. So expand x plus 5 squared, and this one, and then the 49. So expand that, we get x squared plus 10x plus 25. So this is the perfect square trinomial of this. And then for y minus 2 is y squared minus 6y plus 9. You try your foil or the shortcut, the square for the first term, square the first term, and twice the product of the first and the last term. So twice of x and 5 is 10x, and square that to get this one. And then here, square the first term, twice this is negative 6y, and positive 9 for the square of negative 2 equals 49. Then arrange and combine. So arrange, so x squared. Arrange and combine the constants, so we have x squared, then y squared, and then the 10x, and then the 6y, and then combine the 49, the transpose, that's minus 25, and then plus, so it's minus 9. So the general form of this given is x squared plus y squared plus 10x minus 6y equals 15. So we have here the graph of this general form of the circle. So we get here the center, which is negative 5 and then 3. So this is center, and then we can find that the radius is square root of 15. Since it's not a perfect square, so let the radius be square root of no, this is not the square root of the radius, not the square root of 15 is because this is the general form. So to get the general, or to get the radius, then we can change it to go back to this center radius form. Okay, so that's another example. So I'll be giving you another video also, which is from the internet, that can help and guide you on how to solve. And I also give examples in the learning kit. Okay, so God bless everyone and stay safe. Bye-bye.